Not get the relationship between 1 degree and 69 miles on a plane. Absolutely
Correct.
not. Roohif's challenge is absolutely right on, because that the one thing is what sextants rely on, and you cannot, and that for that you require a radius, and you cannot get that relationship on a planar Earth.
With a triangle.
Rumpus and Roohif are being 100% dishonest. If you go to a right triangle calculator and you put in for the baseline 69 miles and 1 degree for the angle, you get 39.58 in a triangle.
Okay, so
This
Rumpus, what responses within the planar stationary Earth community have you heard for that in your journey?
None.
Yeah, they just pull 69 miles per degree out of their ass with no.
So according to Roohif, we pull 69 miles per degree out of our ass. And what we're going to do is go to the triangle calculator. We're going to put in 69 miles. We're going to put in 1 degree. We're going to see what we get. And then we're going to extend it on out from there.
The global method, they just say the globe is, they just take that as red, and that's only been proved in global geometric maths, and they just use that without claiming where they got it from, and they got it from R.
100% correct, Rumpus.
Wow. Roohif and Rumpus's levels of dishonesty are baffling. But we're going to put them to the test, so you heard some specific claims. Rumpus said, we just made up 39.58, that it doesn't work with a triangle. It doesn't work. It only works on a curved surface, and we hijacked it. We're going to put that to the test. Roohif said that you can't get 69 miles for 1 degree with a triangle. We're going to put that to the test. So anybody who doesn't know how the triangle calculator works, just a quick breakdown. The regular A, B, and C represent the sides. That side A is the height. So that side represents us at the bottom and Polaris directly over top. So what we'll do is we will start off underneath Polaris at 90 degrees, and we will move 69.1 miles away from it. We'll take a measurement in the sky, and it'll measure 1 degree. Let's see if it works. So we'll put in 89 degrees. We're no longer 90 degrees, we're 89. And we calculate it, and I'll be dipped in shit. 3958.7, the exact Earth radius. So who hijacked who? Do y'all really think that is a coincidence that with a flat baseline we get a height to Polaris of 3958? So we put their claims to the test and they were dead wrong. I think they're being dishonest. But we're going to further test the claims, because let's see what happens if we keep moving miles. Let's compound the miles and see what happens. Let's see how many degrees we get. So we started off 90 degrees underneath Polaris and we moved 69.1 miles. And that was 1 degree, and that gave us 39.58. So we put in 39.58. Now we're going to double that and put in 138.2 miles. Let's see if that equates to 2 degrees, which will put us at 88 degrees. What do you know? 88 degrees. Okay, let's try and go another 69.1 miles. And we're going to travel, so now we're 3 degrees underneath the 90. I mean, out from underneath the 90. 207 miles. Calculate. What do you know? 87 degrees. Wow, looks like it's working out. Every freaking 69 miles I travel, it's changing by 1 degree. You know what? Let's just try 691 miles, which should be 10 degrees. So 691, and look at that, 80 degrees. We started at 90. We've moved 1 degree for 69 miles. Let's go ahead and try 15 degrees. So 15 times 69.1 is going to give us 1,000. So we're going to move 1,036.5 miles. So we're going to put in 1,036.5 and 75 degrees. Right on the dot. Okay, let's try and do 20 degrees. So 20 times 69.1. And let's see if we're still moving a degree every 69.1 miles. Let's see, 1382. 1382 and calculate, and 70 degrees. Well, what do you know? They are lying. They are being dishonest. The 69 miles per degree does not work on the surface of a globe. So we tested 69 miles per degree, and it worked all the way out to almost 1,400 miles. Okay, now, admittingly, it starts deviating some. Okay, it's not that bad until you start getting thousands of miles away. But what do we know happens with light? Okay, in whatever model, it refracts. So there's a simple equation to fix this, and it's right here. There's one revision to this to convert it to latitudes, and it reflects in every celestial navigation equation that I've seen yet, and it's 90 minus A. So instead of A over 90 times D, which is triangulated distance, times point A, it's 90 minus A over A times D times point A, 1% of the angle. D is the triangulated distance of 90 minus the measured angle in reality. So we're basically using cosine or the co-altitude, which only works on a flat plane. I've still yet to get an explanation how they're using cosine and co-altitudes, but their line's bending. So how can their top line be parallel with the bottom line, much less the crazy distances they use? But we've shown that they have hijacked planar mathematics. They have hijacked measurements with a flat baseline, which do not work on the surface of their sphere. They have to move the measurements down to the center of a sphere. So they have totally hijacked reality, basically.